Hi everyone, today we're going to be talking about modeling using scatter plots and approximations. Modeling is when data is reviewed and analyzed. By looking at trends in the data, one can decide what function would be a good one to model the data with, a process called regression. To be able to identify patterns in data, it will be particularly helpful to be able to name the basic function shapes. Recognizing the shape of each function will become more beneficial as the section progresses. It will be particularly important to recognize the name for each function shape. For now, just focus on these specific function types. So the first type of model we want to look at is a linear model, and there's two particular types we can deal with. There is a linear model with a positive trend and a linear model with a negative trend. So you could say positive trend or increasing, and the second kind has a negative trend, or you can say that it's decreasing. And when we started the unit on linear equations, we were introduced to the equation y equals mx plus b. Another one that you might see when we start to do regression is f of x equals ax plus b. And most of the quarter, we've been saying that m is equivalent to the slope. But when you are looking at it on your calculator, the calculator will often use a, and that's because m usually represents something else related to matrices. If you don't know what that is, don't worry about it. Not a huge deal. And then for quadratic functions, we have one where it's facing upwards, or we have another quadratic where it's facing downwards. And recall that when it's in standard form, the upwards facing parabola is when our a value is positive, so when a is greater than 0, and then it faces downwards when a is less than 0. And remember that the standard form of a quadratic function is f of x equals ax squared plus bx plus c. So again, those are the two types of quadratics that we will see when we are modeling, and it either faces upwards if a is positive, and it will face downwards if a is negative. So the next function that we are going to look at is the logarithmic model, or the logarithmic function. And if here this was our y-axis and this was our x-axis, a logarithmic model or function would grow really fast at first and then grow very slowly after that. And if you are ever familiar with a Richter scale, which is used to measure kind of the intensity of an earthquake, so if you've heard the news and they said like Japan, off the shores of Japan, there was a magnitude 7 earthquake. That magnitude is measured by a logarithmic scale. And the reason that they use that is to make really, really large numbers scale down so that they're more easily usable. And for a logarithmic function, it's going to look something like f of x equals a plus b times the natural log of x. So notice here I have ln in cursive, and all that means is the natural logarithm. If you open a calculator, the natural log button, at least on this TI here, is to the left of the 4 button. And then the two exponential models that we've really been dealing with is when it looks like that, and that is called exponential growth. And then the second one we saw was something like that, and that is called exponential decay. And recall that in general, an exponential function looks like a times b to the xth power. And we have exponential growth when the b value is greater than 1, and we have exponential decay when the b value is a number between 0 and 1. So those are the 4 types of functions that we will see when we are using modeling throughout this unit.